Welcome to the second part of the Rapid Diffs front-end deep dive, and in this part we'll cover the client side of the Rapid Diffs application. As we've explored in the previous video, we have two types of applications. The first one is server and the second one is client. The server is rendered on the Rails and the client is rendered inside the browser when we have the server side rendered. So in order to initialize our application, we have to use this create rapid diffs app function that is located in the app assets JavaScript's rapid diffs index.js. That's how we mount and start working with the rapid diffs server-side application on the client. We can look at example here. For example, here's an example for the commits page. So we create this application and we initialize it. Let's go over and look at how actually the application works. Let me close all of this. So this application does a bunch of things. First of all, it mounts all of these components. So the view control settings and also file browser. And it also enhances existing div files and streams the rest of the div files. So these are the four main functions this application does. If we go into the look into the init function, we will see exactly that. So it will start streaming divs if it's if you are not lazy loading. And lazy loading is when you don't render divs, for example, on merge request creation page. You just render overview tab and the divs are kind of hidden. When you click the changes tab, then we start reloading divs. And reloading divs basically loads all the divs starting from the first file, but stream remaining divs loads only the divs after the first 5 files. As that depends on the offset, which is defined on the server, so you don't have to worry about it really. Then we do some event delegation. Event delegation is used for the div files to handle clicks. So each time you click anything on the page, like this button or the copy button, anything, it goes through this delegator, which looks up the closest div file that happened to the div. So inside of the div file element, it will find exactly this element, and then it will trigger a non-click method on the div file instance. And I'll explain what div file means actually later. And we also delegate intersection observer events. So when we scroll through the page, we constantly checking which files are visible and which files are hidden. And all of them receive this on visible and on invisible function calls. So these are defined on the div file element itself. And we actually can verify this if we go to a div file, for example, and say on click. It actually has this function when we say on visible. The function is also here. So that's how we delegate events. This is done for performance reasons, because we can have, for example, 200 files, and each of those files will have at least 10 different click handlers. So you multiply those and you get a lot of elements, a lot of event listeners, and that's what we want to avoid here. So delegation level happens on the application. Then we register our custom elements, and as we've shown you here, our div files are using custom div file element, and that is part of our 3-layer architecture that I'll explain after this. Then we render the header, that is this part exactly, and sidebar, this part, the file browser, and the divs list. So div list is actually doing streaming and some fixes for Safari and Chrome. And also it handles communication between the loaded div files and the file browser. So, for example, when we start loading files, let's refresh the page to see. to see this in action. You can see some of the files are having these spinners. That means the file is not yet loaded. And we determine if a file is loaded or not by looking up into this diff file mounted event. It essentially happens the same time as we call the mount on the diff file element, but I'll explain how it works after this. So if when a file mounts, it notifies the Pinia store using this function add loaded file. The same store is used in the file tree component, and it can remove the spinner for a particular file. So that's how communication happens. So rapid diffs on the client side have a 3-layer architecture for adding any new features and basically structuring the data flow. So the 3 layers are our web component, which you see here. Then each of the web components can have adapters. That is our second layer. You can think of adapters as of sort of mixins in Vue that can enhance your existing logic, can add some features to some hooks like mounted or your clicks. And then the third layer is your actual components that rendered inside the diff file. So when we create a rapid diffs application, we provide it with adapter config. It's defined by default here. So viewer adapters, this is our configuration of adapters that will be used by the diff file web component. And it basically maps our viewer to a collection of adapters that has to be run for this particular viewer. And the viewer is this part of the diff file, like when you see diff lines or when you see image diffs. And it's also set here in the diff file itself. Yeah, if you can see here, it has a viewer set to text in line, which means this particular diff component will have to load all of these adapters when it's mounted. Let's look at some of the existing adapters to understand how they work. So adapters can listen to 2 types of events. First of all, these are objects that subscribe to different events. First type of events is clicks. And clicks are your clicks on elements like buttons that have data click set on them. So if you see button with data click, it means it should be handled inside the adapter. So this click will be redirected to this particular adapter. It will receive the event and the button that triggered this click. And inside an adapter, you are free to do anything. You can use Pinia stores, you can use Vue components, you can use regular JS to modify the DOM. You can use diff file sync to store some information. So how it works is that diff file will trigger some events. For example, if a click happens, then it goes through all of the adapters for this viewer. Let's look at the adapters. So first of all, it looks the adapter config from the application. Then it checks if the viewers are matching. So we check the viewer defined here. And based on this viewer, we grab the configuration for adapters. And for each of the adapters in this configuration, so in this configuration, if any of those have a click handler that has click action called toggle options menu, it will be handled. So in our case, I think it's only one adapter that handles this click, and it does a bunch of stuff. And also each of those adapters is provided with a context. It's a special object that has some useful data for the adapter. So it will have app data, which is our application state defined here. So this is provided through app data. Then we have the diff element itself, which is not the web component. It's actually this article element. And it's used because if we were to provide the web component here, it would also provide all the methods that are available on the web component, which we want to avoid because adapters should be kind of unaware of the stuff that is happening in the web component. Then we have a sink, is basically a temporary storage for your data. Think of it as a data function in a view component, but it's used for intermediate state. For example, when you remove a component from a DOM tree, but you want to keep your data that was on the component, you put it in a sink, then you restore the component and grab the data from the sink. Then we have the data, which is data here. So data, file data, that is provided in this field. And we have two functions so far. So trigger is triggering an event. That is a custom event that will happen inside the diff file. And that is useful if you want to communicate with another adapter. So for example, your button should collapse some other section in a diff file that is handled by another adapter. You will trigger an event and subscribe to this event in another adapter. And we have replace with, basically function to replace the whole viewer, the whole file with another HTML. For example, it can be used to show collapsed files. So let's look if we have any of adapters that using custom events. For example, here, so disable diff site adapter. It's an adapter to allow us work with parallel diffs, and it's watching for the visible and invisible events. So I told you about two types of events. First type of events is clicks, and the second type of events is our adapter events. You can look them up here. And the invisible events are tied to intersection observer. So each time we see a file inside a viewport, the visible event is triggered. When it leaves the viewport, the invisible event is triggered again. And you can do some useful stuff. For example, in our case here, we disable diff site that is opposite to our current selected site. So when we select a text on the right side, the left side is completely disabled. If we were to, for example, remove this, let's see. I think a page reload will happen first. Let's wait for it to load. And if we were to select text, you can see both sides are selected, which is not what we want. So we have to use a JavaScript solution for that and disable sites based on the visibility of the diff. And we also have a lot of others adapters used for other stuff. For example, expand lines. It also, as you can see, handles the expand lines click. If you go to a button, we can see data click equals expand lines. That's exactly what's called in this adapter. And it also does a bunch of stuff. Even so, you can see it doesn't have even a view component. It's purely DOM manipulations because there's not much else here. And we simply insert our HTML that we received from the server as is into the page. That is all handled by the adapter layer. Same goes with images. So images actually mounts a view component that is responsible for image viewing, and it receives data coming from the viewer. So in this case, we query for data image data, grab the data attributes and grab the image data. Same goes for other attributes here and adapters. So if you want to create a new adapter, you would usually put a file here and you would decide where it belongs. So you would go to the adapters configuration. It's located in the app folder. Here it is. And that is our default configuration for adapters. For example, merge requests page might have a different configuration, and commits page might also have a different one, because these applications, they also have discussions and also more advanced features like code quality reports and testing reports and all other bunch of stuff that we don't have on other pages. So for example, compare revisions is just straightforward diffs. It doesn't have any of the advanced features. So we would have a different viewer adapter configs for these pages. And you would usually create a new rapid diffs app class for those. All right, so this was the Freela architecture. That's how you develop it. You add a new adapter here or modify an existing adapter here. Put the adapter in the adapters folder. You might use some, you may create even a folder for your adapter here to add some components if you'd like. But so far, the components we are using, they're all coming from existing implementation. For example, the image viewer, it's using the view shared components. So that's why you don't see a component added in this folder. But in your case, if you're working on something different, you might want to create a component right in the adapters folder. That's perfectly fine. We also have a store folder. So this stores folder allows us to share the logic between the diffs list, file browser, and the view settings. And it controls how the application works and manages all the state. The app visible state is used for merge request creation form. So for example, when you hide the application and resume it again, we might disable some features on the page. So for example, like shortcuts, right? So when we have this Shift F shortcut to toggle file browser, when we leave this page, we want to disable this. So that's how we control it with app visible state. And we have two other stores, which are diffs list and diffs view. Diffs view is essentially mapping settings from this control to a state in this store. And it's also having some extra params. So it has view type, which is our control for the inline or parallel view. Single file mode is currently disabled because we don't support it yet. We have some endpoints for fetching, for updating user preferences that is used for white space. We have the streaming URL, and we have the diffstats endpoint and the diffstats themselves with overflow. Diffstats are used for the file browser, and overflow is when you have a lot of diffs, you will see this yellow message saying you have too many diffs and we have to limit them. So the most important part here is how we handle updates, right? So when we update our diff view, which you can see here, for example, we change the setting here, we have to reload the whole list of our diffs. And we do that by using another store called diffs list, and we call the function called reload diffs. And this store controls the presentation of the diffs list on the application. So it's used not just in the diffs view, it's also used in the app itself. If you go to the application and we look how it works. So for example, stream remaining diffs, it also calls use diffs list, the same store here, and the function that's responsible for streaming. And this store is a little bit more advanced. It's kind of complicated because we have to use debouncing. This is a special kind of debouncing that handles also errors inside of it. And it allows us to, for example, trigger these controls as fast as possible and don't have any issues on the page. For example, if we are changing this control in the middle of streaming, it actually cancels the stream and cancels the request. So we don't have any issues on the page. And we just start streaming the new response right away. So we don't have to wait for the whole thing to complete. We just switch it on the go, which is super cool. And it's done with this advanced debounced wrapper. So what all of them do is they call for the streaming of the diffs. Let's look at it right now. So for example, reload diffs. We have this render diff stream action. And what it does is it grabs a stream object. I don't know if I can see the type here. But it essentially grabs the stream object, grabs the container, and puts everything that's coming from the stream inside this container. So in the previous video, I explained to you how the streaming works on the server side. We have our Rails responding in a streaming fashion with the diff stream endpoint. As we can see here, like this is our streaming endpoint. And HTTP allows us to send these diffs in smaller portions. So we see here content download is our streaming time. That's how much time it took for the diffs to complete streaming. And on the client, we do essentially the same process. We have this stream object, which is the stuff that fetch returns us. So fetch has a body object, which is a readable stream. And it's a stream of bytes that that we receive directly from HTTP response. So each time this response gives us new bytes, we receive them in the body. And we use this render HTML streams function to render them inside of our document. For that, we need a container. In case of reloading streams, in case of reloading diffs, we use this data diffs list element. And you can see the streaming element. That is how the content gets added here. This element doesn't actually exist inside of our original document, which is a weird thing to say, but I'll show you how it works right now. So here we have the same story. This render HTML streams function abstracts away dealing with streaming. And what we do here is we create a new HTML stream. And what it does is it creates a new HTML document. So there is a function called create HTML document. And inside this function, we can use the write method. It is exactly the same write method that you have in your document originally. So you might have seen really old add code that was used for tracking or adding some analytics to the page that used this method and basically added script tags right away when the HTML was loading. But we can use it for loading streams in a separate document. So we don't have to patch our existing document because it's not possible. You cannot call this in our current document. So if we call this on our existing document, that's right. Yeah, you can see it says avoid doing that, because when you do so, you replace the whole thing. But in a newly created document, it's actually okay. We can write to it, and that allows us to stream content as soon as it's fetched. So as soon as we fetch the bytes from the response, they're sent immediately to this document using document write. And this element is then pulled back into our original document. So that's why we have two mounting elements. The first element, let's try reloading it again. So the first element, this is our host element in the original document, and the streaming element is the element coming from the streaming document. So we just grab it from this document and insert it into our original document. This sounds confusing, I know, but if you work long enough with this, it will get better. And that's how we handle streaming with our Pinia store. You might be wondering, why are we using this in the store? Because exactly because in order to exactly simplify working with streaming and controlling it with other components. So our application is responsible for loading streams, and also our controls should be responsible for doing that. They should be able to reload the stream as soon as possible. By having this reactive store, we actually can do that independently. So if the application wants to reload diffs, it also can do so through this controller store. So if you want to share some of the logic between application and between your components, you should create a new store here and use it wherever you want. The same goes for a diff file. So diff file is designed in such a way that you can import it in any place of the application. So if you want to, for example, find a specific file by a diff file hash, you can do so as well as in the application. So I think it also already imports it, right? And you also can do this in any of the adapters. So I don't think we have an example of this yet. Let's look. Yeah, we don't have an example of it yet, but if you need to do so, you're perfectly able to do this. Also, one more note on the adapters. When you work with an adapter, you should keep in mind that they don't have an instance. So if you have this mounted hook, it's called whenever a web component is mounted. It doesn't have any state. So this adapter is stateless basically, and a diff file just goes through them. It doesn't create an instance of each of the adapters. So you can create some things here, but you should be really careful with what you do in the adapter, because it can create multiple, it can do multiple calls of the same hook. For example, mounted will not be called multiple times because it's just happening during mount. But for other things like visible and invisible, it gets called all the time. And if you need to preserve state, I suggest you use sync. That is on the context. That's how you keep your state inside of the adapter. But you should not create new elements here or new objects, because they will be created each time this called, and you might cause memory leaks because of that. So be aware when this is actually called. Okay, one last thing I wanted to show you is how we mount our diff files. So mounting diff files is not straightforward because we have to decouple the diff file itself, so this diff file element from adapters and also from the application. So how do we do that? So in order to do that, we have this register custom elements thing, and we have this special component called diff file mounted, and it performs two crucial things. So first thing is that when we're working with streaming, we need to know when the component is actually fully rendered. And one of the problems with web components is that their mounted hook triggers immediately as you insert the first name of the tag. That means you might be actually in the middle of the streaming and you have like half of the file, but the mounted hook is already triggered, which we don't want to have. That means we have partial state, and that can cause a lot of errors in the code. So what we have to do is we have to insert one component as the last element of the diff file, and that tells us that this diff file is actually fully loaded. And that's what's happening here. We have this connected callback, essentially the same as mounted hook in Vue. So when this is inserted into HTML, this connected callback is called, and it goes to a parent element. In our case, it's diff file, and it calls a mount method on the diff file, providing an app context. So we look at the mount method on the diff file. It grabs this up, it assigns this to the state and does a lot of initialization steps. And that's how it's working. So in the application, we first need to create this and provide the instance of the Rapid Diffs application. Then as soon as this component is inserted, the instance of the Rapid Diffs application is inserted directly into every diff file. Because of that, you are free to import diff file directly in adapters, and you are free to import diff file directly in the Rapid Diffs itself, which is a pretty useful thing to do. Yeah, I think we've covered all of it. And if you have any further questions, please ask in our Slack channel, Rapid Diffs. Thank you for watching. See you.